and we're going to pose a series of questions to the panel members and then have chance for you to put your questions to them. But do please, as I say, type them as we go along. Okay, so this evening then we have Professor David Hanna, who is an alumnus of the University of Birmingham. He's a professor of hydrology, UNESCO Chair in Water Science, a Royal Society Wolfson Fellow, and College Director of Research for Life and Environmental Sciences. He's recognised internationally for his pioneering research that seeks to understand water cycle processes, hydrological events, floods and drought, and water-related impacts on ecosystems and society. So welcome, David. We also have with us Professor Stefan Krauser. Stefan is a professor of ecohydrology and biogeochemistry and leads the Water Challenges theme of the Institute of Global Innovation at the university. And together with David, he is leading the UNESCO UniTwin network on eco-hydrological interfaces, addressing wicked water problems around the world. His interdisciplinary research combines the investigation of legacy, old and emerging or new pollutants and their impact on water resources, ecosystems functioning and human health. We also have with us Professor Izolt Lynch. Iseult is a professor of environmental nanosciences and the Strand Lead for Pollution in the Institute of Global Innovation Water Challenges theme, as well as leading the Environmental Pollution Solutions Emerging theme. Her world-leading research investigates the environmental health and safety of engineered nanomaterials and incidental microplastics, with a strong focus on understanding the interface between materials and the living environment. She was awarded the Royal Society of Chemistry's John Jays Award in 2020 for her contribution to environmental science. Well done, Iseult. And then finally, our final panelist this evening is Dr. Rachel Cooper. Rachel is a research fellow in the Governance and Social Development Research Centre in the university's International Development Department. Rachel is the lead researcher for a water security and climate change learning journey across the UK's Foreign, Commonwealth and Development Office. Her work to date is focused on access inequalities, water finance and the importance of water for climate resilience. So we have a great panel this evening. I should say as well that I'm a professor of environment and development, and I'm also in the International Development Department at the university, and also an alumnus as well. Okay, so I've introduced the panel. We're going to start very briefly with an introduction to the topic, and I'll hand over to Stefan for that.
Thank you very much, Fiona. Yeah, let's start with a very brief introduction that Rachel, Iseult, David and I have put together for this evening. If we are looking at the background of this presentation, it's a slide that presents conditions as you may have experienced today outside. It's a bright day, it's decently wet, there's a good amount of water around, and as you see here on the slide of the Darrow campaign of Birmingham in Action, there's a lot of water around, unfortunately, and that water looks quite clean as well, so it's a lot and it's clean. Unfortunately, that's not the case for large parts of the world. In fact, more than 2 billion people actually lack access to safe water for a whole lot of purposes, and the lack of access to that water impacts the livelihoods, the education, the personal development, the safety, the social justice and gender equality in many communities, and most of all also the health. Predominantly through diuretic disease, which makes almost 4% of the global disease burden, diuretic disease that is related to water, polluted water or water shortage, is a real burden to our health systems. Of course, that roughly 4% around the world is not equally distributed. And it contributes to 1.5 million avoidable deaths per year, according to the World Health Organization. And unfortunately, of that, to more than 250,000 avoidable deaths of children under the age of 5 as well. So it's the second most frequent cause for death of infants under the age of 5, according to the World Health Organization. So there's a huge problem with regard to access and safe access to water that affects not only low and middle income countries, but predominantly low and middle income countries. These challenges that we are facing regarding safe access to water are further accelerated through dramatic changes that we're experiencing in our water cycle in this day and age. We see increasing frequencies as well as magnitudes of extreme events, extreme hydrometeorological events, which bring us either too much water or cause too little water. So we talk about flooding and drought, and quite often, and associated to that, water that is too polluted. And that involves dichotomies like having actually a lot of water around you, but it being so polluted that it's not safe to use. So with climate change and global climate change, the challenges that we are facing regarding safety to water and safe access to water is even further accelerated. As Fiona mentioned, Izolt, David and I have, together with other colleagues at Birmingham and Northwestern recently, looked into how the availability or unavailability to the announced most efficient measure to reduce the spread of COVID is affecting the safety and the health of people globally. WHO earlier this year, when the COVID-19 pandemic emerged, had announced that the single most but also apparently easy way to prevent the spread of the SARS-CoV-2 virus is regular washing of your hands with water and soap. And that sounds utterly easy from the perspective where we are sitting in. However, it requires water, so water needs to be available. Water needs to be available in suitable quality for that, and water needs to be accessible. And that, of course, as we briefly alluded to and want to discuss with you tonight, is by far not everywhere the case. We have not only focused on identifying the challenges in this, but also proposed a whole suite of strategies to implement solutions. Some of that solutions have to do with technological improvements, and that can be hardcore engineering, infrastructure solutions, as well as using nature and nature-based solutions to improve safe access to water, behavioral changes, as well as economic and political incentives. And we put a couple of them up here, and we are looking forward to discuss them in greater detail with you over the next 45 minutes or so. So much about a brief introduction to the topic, and I hand back over to you, Fiona, for the first questions.
Great, thank you very much, Stefan. Okay, so I think we'd better kick off with the first question on just what are the wicked water challenges or wicked water problems. So perhaps that can go to David.
So it's great to be part of this Bringing Birmingham to You alumni event on wicked water. So when we're talking about wickedness, it's not about the degree of difficulty or the nature of the problem. Rather, wicked problems are different because traditional approaches cannot solve them. So we need new ways of thinking about the issues, doing our research, and also developing innovative solutions. So our work at the University of Birmingham aims to develop some really transformative approaches to tackle wicked water problems. And these problems are wicked because they're multifaceted, they're often interconnected problems, and they're very difficult to solve due to lack of data, and also in many cases changing human requirements and needs. So for example, to meet the aims of our UNESCO Chair in Water Science, we're working on thinking about new ways of addressing, but indeed rethinking, the grand challenges about water in a changing world. And this pioneering research is really, really important. It's vital to understand transformative change towards sustainable development of finite water resources, and also towards thinking through some of the interventions that we might be able to use to enhance the resilience of freshwater ecosystems to change.
Okay, thanks for that, David. Perhaps you could tell us a little bit more about how the water cycle is changing and why.
So you might be surprised to know that the global mass of water actually is a fairly constant amount over time, But what's really interesting is the way it's partitioned between our different major water stores, between snow, ice, groundwater, soils, rivers, and the atmosphere. And that varies across space and across time and depends upon the climate system, but also the river basin or watershed controls and processes. So the scientific community are agreed that the Earth's water cycle is changing, and there's widespread understanding that climate change is accelerating both atmospheric water vapor, clouds, precipitation, and runoff patterns, and also how water is stored in cold regions as snow and glaciers and in the subsurface as groundwater. So for example, if we consider our lower atmosphere, as it becomes warmer with anthropogenic climate change, evaporation increases, the amount of water circulating in the atmosphere increases, and one of the results of this is higher atmospheric moisture that then rains out as very intense precipitation events and extremes over the land. And also because of the warmer temperatures, that precipitation tends to follow as rain rather than snow. In many parts of the northern hemisphere linked to this, springs become earlier or spring-like conditions become earlier, and that's resulted in a shift towards snowmelt peaks being earlier in the year, while in glaciated regions, regions covered with ice, we have the glaciers shrinking there and meltwater, which is normally sustains summer flows, declining, so there's less available in the low flow season. And that has really significant impacts during the high water demand seasons of the year in the summer and in the autumn because of the reduced amount of fresh water. Also associated with the high temperatures, we have increased drying of the land surface, which in some areas has increased the severity and the duration of droughts. And our research modelling droughts up to the end of this century shows that there's going to be regional hotspots for increased drought activity in South America and Central and Western Europe. And there we're expecting droughts to increase by about 20%, which is a really marked change.
Okay, that's great. Thanks a lot, David. I think that gives us a good sense of just how the water cycle is changing. So perhaps we can move on to Stefan then and ask about how these changes in the water cycle are affecting water quality.
Yeah, thank you, Fiona. So as David alluded to, we see increased frequencies and magnitudes of extreme events, both with regards to floods as well as to droughts. And actually the impact of this hydrometeorological extremes, which can be quite disastrous throughout the world, but also in this country, with regard to health impacts as well as cost, it's often rather the water quality that is having a larger impact and a more dramatic impact. With regards to occasions when we deal with too much water, so floods, they on the one hand side connect pollutants that normally would not be connected to waterways. So it connects sources of contamination to receptor systems, which could be us and our food chain. Of course, we see frequently failure of infrastructure like wastewater infrastructure during flood events, which enables the spread of sources that normally would be separated from our fresh water, our water that we assume to be safe to use. So that changes in the frequency and magnitude of the occurrence of floods has a major impact on pollution events as well. On the other scale, on the other side of the scale, the extreme droughts that we have been experiencing throughout Europe, North America, Africa, Central Asia over the last 2 decades, they cause water quality extremes as well. On the one hand side, very simply because the amount of contaminants stays, water evaporates, and we basically increase concentrations by that. Water warms, and warm water stimulates biological activity, so we see a lot of increase in the spread of particular pathogens. And of course, less availability to open water sources during any droughts is shifting the access to safe water as well. Okay,
that's gives us a good understanding then of how water quality matters and how pollutants affect human health. But could you tell us a little bit more about which specific water-related pollutants we're looking at that are concerned for human health?
Yeah, so there are really different types of pollutants we are dealing with, and one of them are geogenic sources. Like probably one of the ones that everyone will have heard about is arsenic. So these are pollutants that already are in the environment that stem from the rock, basically, where groundwater sits in, and where our use of water has changed the redox conditions, the oxygen content in the water, and with that mobilizes a lot of these. And Iseult and I have been out at the Ganges for some work in that have the impacts of arsenic-related cancers. And then, as you mentioned in the introduction, we are dealing with a mix of both legacy nitrate, and people may have heard about the nitrate time bomb in particular in groundwater, or chlorinated solvents, as well as emerging pollutants, so that are like pharmaceuticals or pathogens in the water, and to a large degree particulate pollutants like plastics, in particular microplastics, where here in Birmingham we are working on as well, which are carriers for a whole range of other pathogens and contaminants.
Okay, thanks a lot, Stefan. I think we'll move now to Iseult and ask, perhaps you could tell us a bit about how the main environmental and human health problems that can arise from flooding and drought.
Perfect, thank you, Fiona. And I think Stefan has introduced the issue really nicely. So some of the things that we're starting to see, and I'll take again the microplastics as an example. Often over time, the plastics will sort of settle out into the sediment, where in a sense they're removed from the water column. And that's one way of removing them and minimizing the harm from them. And similarly, lots of other legacy pollutants collect in the sediment. But often then when you have flooding events, that sediment gets churned up, and all of those pollutants that have been captured in the sediment are then released. And when the rivers overspill their banks, that gets spread out then on agricultural land, and potentially then can also contaminate groundwater and drinking water. But also then anything that's on the land can then get taken up into any of our crops that are grown on that land. So it's sort of a recycling of pollutants into the environment. And Stefan also alluded to, of course, the fact that particles provide a surface, and on that surface they carry other pollutants with them, but also they can provide a surface or a substrate onto which other bacteria and things can gather. And what we've noticed, and research at Birmingham and elsewhere, including some of our partners in China, for example, we have found that the communities that enrich on particles are different than those that are in the environment generally. So particles do provide substrates to change potentially the availability of some of these pathogenic bacteria as well. And it's also things like, if drinking water and runoff water mix, or sometimes depending on the infrastructure available, even in developed countries. So I think Sydney Harbour is a real classic example here, where during very heavy rainfall events, the water spills over into the drainage system and mixes with sewage. And then you end up with very high concentrations of pharmaceuticals and other things in the water, which makes it unsafe then for recreational activity. So it's a whole combination of old infrastructure combined with changing flows of water and changing water cycle, as David and Stefan have said.
Great, thank you. In the introduction, Stefan was talking about the problems of there not being enough water for hand washing. But what about hand washing with dirty water? What are some of the challenges associated with that?
Well, it's an interesting concept and an interesting approach. So we've been reading a lot around the subject as well. And with dirty water, you are then exposing yourself to, for example, whatever chemicals are in there, but also more importantly to bacteria. So even things as simple as E. coli or other gastrointestinal type bacteria, which will then cause diarrhea. And diarrhea for us in the developed world isn't a very big problem, but diarrhea in young children in developing countries or low and middle income countries is associated with up to a 25% stunting in growth for children who've had more than 5 episodes of diarrhea before the age of 2. And that's very, very severe. Also, there's emerging evidence now that, for example, E. coli, Shigella and other bacteria that are associated with dirty water can also impact on the effectiveness of vaccines. So even if we do get towards vaccines, they might be a challenge. But actually then washing, so one of the proposed solutions has been that, you know, where you have to make a choice of whether to use your clean water for cooking or for your animals or for hand washing. One possibility that has been proposed is that even if you're using what's sort of called grey water, so the water that's coming out of your laundry, for example, that's better than not washing at all. So, but the key challenge really seems to be availability of both the water and soap. So in the Nature Sustainability paper and the WISE study, there was also some detail about, you know, that not everybody has access to soap. So it isn't just water, it's water and soap that's needed really to address particularly the COVID, but any viruses really.
I think that takes us nicely then to a question to Rachel on just, you know, given what COVID-19 has revealed about access to water, can you tell us a bit about some of the challenges in providing sustainable, safe water access in low and middle income countries?
Thanks, Fiona. And yes, just to start with a bit of context, as I'm sure a lot of you know, the UN Sustainable Development Goals have committed us to a target of universal access by 2030. But COVID-19 has really shown up a number of challenges that we're going to face in reaching that goal. And so just to highlight three of those really quickly. The first is that often in sort of urban areas, we've got a utility that's responsible for providing water, but they can't service the existing demand and they haven't got the resources to maintain or extend provision to the poorest. As we all know, water comes from a system, you know, from storage through to treatment, and that system obviously has costs. And when you've got a utility that can't meet those costs, that can actually create additional barriers for the urban poor in accessing water. One of these is that it can result in a really high connection cost. So you maybe want to get your household connected or your plot connected to utility water, but that high initial cost is a massive deterrent. And you might find that even if you do meet that cost, you're not going to get 24-hour access to water because we've got intermittent supply problems. So that also deters people. And it means that what they end up doing, the sort of urban poor, particularly informal settlements populations, is relying on private vendors and really expensive forms of water. So there's a whole challenge around how to make utilities sustainable and how to sort of make water affordable for the urban poor. Secondly, we've got problems around data and around indicators. COVID-19 really showed that a lot of water planners and city planners, particularly in low and middle income countries, didn't necessarily have adequate data about what the conditions were in informal settlements or in the poor communities, who had access, who didn't. And that really caused problems about where to open up new water sources. And secondly, sort of in terms of indicators, we focus very much on the percentage of people or the proportion of people that have got access to safe water. And we sometimes confuse that with having access to water security. So there's a lot of anecdotal evidence from Africa, particularly during the first wave of COVID-19, that people who could normally meet their water demand, so they could afford to buy, say, their 20 or 25 litres of water needed to support their basic needs, couldn't afford to buy additional water for hand washing. And then we hit up against a number of the challenges that Iseult was sort of just talking about. And thirdly, we really need to talk about questions of how to ensure the sustainability of supply. So it's not just connecting people, connecting populations or cities, but how do we make sure that that supply is sustainable? And a quick example of that is the capital of city of Ivory Coast. 70% of their water comes from one single reservoir. And that reservoir is shrinking due to climate change. So the government's immediate solution, because obviously the water needs to keep flowing to the city, is to sink some new boreholes and use groundwater instead. But we're also seeing groundwater depletion. So whilst this is an immediate solution, it's not going to be a sustainable way to do access in the long term. And then sort of finally, we've got these massive problems around finance and investment. We just don't have the money that we need to sort of meet these Sustainable Development Goal 6 targets. Thank you.
I muted myself. Rachel, maybe you could just tell us a little bit more about why there is this finance gap.
Yeah, absolutely. Thank you. So to start with, we are really facing a massive gap. Estimates suggest that we need an additional $1.7 trillion by 2030 if we're going to get everyone in the globe access to water. We're also going to need an additional 6.7 trillion US dollars to meet our water infrastructure needs. So things like flood defences and environmental defences, drought protection measures. And we just don't have that money at the moment. And there's a recognition that actually governments or donors aren't going to be able to produce that amount of money by 2030. So now we need to leverage money from, say, the private sector or from investors. And here we hit up against a big problem. If I was to tell you that there's a great economic case for water, that if we invest, we could save $260 billion a year annually around the world in avoiding problems associated with inadequate water supply, you think, great, where do I sign? But actually, when we start talking about the investment case for individual projects, so a new water supply system for a city or a new reservoir, then we hit up into these problems around risk return profiles. So at a really broad generalization, investors want to know about risk. If I lend you my money, am I going to lose it or will I get it back? And what the rate of return will be. And we've got a few problems around rate of return and risk in water for investors. And so very briefly, these four go down to sort of cost recovery. Water is obviously not priced correctly for a lot of users, agriculture, households. We don't price these things properly, so then we can't necessarily recover the costs and pay back our investors. So that makes them think this is a bit of a risky project. We've also got big problems around monetizing benefits. So for example, if we build a new flood defense system, that is going to accrue some private benefits. If you own a business and your business doesn't get flooded, that's really good for you. If you're a home and your home doesn't get flooded, that's really good for people. We're also going to save lives, but it's really hard to turn that flood defense system into a revenue stream that can be used to pay back investors. And thirdly, we've got problems around scale. A lot of water projects are really small scale. So your big investors, maybe your public sector pension funds, they're not interested in these small nitty-bitty projects. And finally, and perhaps most challenging in some ways, a lot of investors don't understand water, and it's really hard to sell water easily in, say, a 30-second elevator pitch. And they don't have the tools to assess these projects. So instead, they choose to go for sectors that are a lot easier to navigate, like, say, roads or telecommunications. So we really need to think about ways that we can improve that risk return profile for water. Thank you.
Okay, great. Thank you very much. And I think we can see from all of the contributions so far that water really is a wicked problem. So perhaps we'll move now to look to see, find out more about some of the solutions and about how Birmingham research is contributing towards addressing these challenges. So David, can you tell us a bit more about what Birmingham research is contributing in this area?
Yeah, so our research at Birmingham maps directly onto UN Sustainable Development Goal number 6, which is all about ensuring availability and sustainable management of water and sanitation for all. So in this context, our research is really relevant and very important in terms of achieving access to drinking water for all, thinking about how we can protect and restore water-related ecosystems in mountains and forests and wetlands and rivers, think about how we can improve water quality by reducing pollution. And as a university, it's really important that we think about how we can expand our international cooperation and reach and support those in lower and middle income countries on water-related research, but also in terms of education to build capacity in individuals and institutions. And lastly, we seek to support and strengthen participation of local communities for improving their water management issues. So we're very lucky at the university. We're going to be in a large and comprehensive university, so we can draw together researchers from across a range of disciplines: science, engineering, social science, arts and humanities. But we meet them together with policymakers and the public to raise awareness of water security and global water-related issues.
Okay, thanks, David. Stefan, perhaps you can tell us a little bit about your research, particularly in terms of identifying hotspots and hot moments of pollution, and you know, how that has contributed in terms of improving water quality.
Yeah, thank you, Fiona. Indeed, one of the challenges that we outlined is that often water quality phenomena are quite episodic. That means we can, within a certain event, see an increase of pollutant concentrations by several orders of magnitude. And that can be very short-lived, but very impactful events, whereas other pollutants can be more underlying, almost like a chronic exposure, but very spatially limited. And unfortunately, the traditional way of analyzing water pollutants is going out, sampling water, bringing it back into highly technological environmental lab and analyzing it. And that limits our ability to actually sample where we really need to have the information, where we need to give decision makers, regulators, water and river basin managers, the information of how to manage surface waters, groundwaters, manage the land use in river catchments, basically. And there's a lot of research done in Birmingham making use of that sensor revolution that is happening at the moment, with a lot of very fancy technology developments that allow us to reverse analysis process, to basically take the lab out into the field, which then allows us to monitor in situ, that means in the space where we're interested in, but also at that frequencies and at that resolutions that really are meaningful, not that are constrained by our ability in person power and time to sample. And that allows us to pinpoint where and when pollution peaks, and that is the most important information we can provide river basin managers, regulators with, because that allows targeted interventions, and during the times and at the locations where pollution gets connected to the environment and can cause an impact there.
Okay, thank you. So it's clear that monitoring water quality is really important, but how do we move from monitoring to remediating polluted sites, Iseult?
Yeah, so that's a really, really great question. And it's really where the focus of a lot of our research at the university is now. And I think it builds very much on Stefan's work and the sensor networks, that if we know where the pollutants are gathering, that gives us good starting points as to where we might be most effective in terms of remediating. And also, if we know what the sources are, we can also start to think about, well, how do we prevent those emissions from ever reaching the water in the first place? So can we think about solutions at industrial discharge sites? So rather than trying to remediate after the fact, can we prevent those pollutants from ever getting there? We're actually in the process at the moment of consolidating a lot of the research that we do and bringing together solutions, sort of technological solutions such as the sensors that Stefan mentioned, but also using those sorts of particles and nanomaterials and nanotechnologies and all of these surfaces to really develop smart devices that not just sense what's there, but then also capture it and maybe, you know, use catalytic conversion to break down those pollutants and convert them into things that are much less toxic or much less harmful, or even recycle those nutrients back to the ecosystems. So really, you know, so combining those technological and engineering type solutions with nature-based solutions. So we also have colleagues, like for example, Dr. Luisa Orsini in the School of Biosciences, who is developing sort of a Daphnia-based solution. So Daphnia are like a little water flea that live in all freshwater environments, really, and using those as a means to mop up and degrade pollutants. But combining those then with some of the sort of things that Rachel has been talking about, the financial incentives, and also then with behavioral incentives. So how do we get companies to change their approach, and how do we as consumers change the approach that, you know, we want to only use recycled plastics, for example. So as individuals, we have a lot of power to drive changes at all steps of products and their emissions and their recycling and all of the associated pollution related challenges.
Great, thank you. So it sounds like nature-based solutions then certainly have something to contribute to remediating sites and addressing water pollution. Rachel, perhaps you can tell us a little bit about scaling up and nature-based solutions and some of the challenges associated with those.
Yeah, absolutely. We're seeing that nature-based solutions are really sort of having a moment at the right now with policymakers and with decision makers, and also with companies. There seems to be this big surge of interest, and we've got a really nice evidence base to show that they can work. There's obviously a lot of factors that we need to get right, and there's some challenges around those. So if I sort of highlight four, the first is the enabling environments. A lot of times policy and as we've talked about, investment, financial incentives, those maybe favour grey infrastructure, so building a dam, pouring concrete, those types of solutions. But if we can change that enabling environment, we can see a big uptake. For example, in Peru in 2016, there was a small change to the law that said all utility companies had to put 2% of their revenue aside to support nature-based solutions and also climate change disaster risk reduction. And this has raised over $100 million to support that in 4 years. So that one small change can really help to sort of scale up the approaches. But when we're scaling up, we really need to be aware of sort of governance issues and equity issues. So nature-based solutions, as I'm sure some of us know already, they use or enhance or mimic these natural processes to help address these societal challenges. But if we're talking about things like, say, reforesting an area or getting farmers to change their land management practices, then we need to make sure that those stakeholders are involved in the governance of the scheme and also any decision-making that takes place. And we also need to be really sensitive to issues of land tenure, of equity and of Indigenous knowledge to make sure that we're not sort of creating new inequalities by using this type of solution. And a third sort of area is around capacity. So a lot of, say, water planners or managers or water engineers in low and middle income countries weren't necessarily trained in nature-based solutions and are really focused on that immediate problem of how do we keep the network going, how do we sustain it, how do we maybe extend provision. So new solutions, such as nature-based solutions, even though they've been around for a really long time, they have quite a long time scale before they can start to see the benefits. So if you're focused right now on your immediate problem, planting a load of trees, which might have benefits in 5-10 years, maybe doesn't appeal as much. So there's a real sort of problem around kind of capacity building and development. And finally, not to sound like a broken record, but there's a big financing problem as well. For certain stakeholders, such as we've seen Coca-Cola and other companies signing up to water stewardship programs, there's an economic and investment case there that's really clear. They need clean water to flow into their production sites to make their products. So you can see why they would invest in, say, upstream water management. But for other types of investors, where you can't monetize that revenue stream or see like an avoided cost that actually benefits you, it's harder to sort of get that investment. We also commonly use cost-benefit analysis tools that maybe don't account for the longer time frames that a nature-based solution needs or the larger sort of land area that you need to do it over. So we need to sort of address some of those financial barriers as well. Thank you.
Great, thank you very much. That's great timing. So we've got really good sense now of what Wicked Water is all about, what some of the problems are and some of the solutions that we're working on at the University of Birmingham. So we've got time now for some questions and answers. And so I'd like to start by inviting Richard Warburg to present his question to the panel. So if that's okay, your camera will be and microphone will be turned on.
Hi, thank you. The question actually is twofold. What role do you think the combination of solar or wind power or any renewable energy to convert seawater to fresh water with reverse osmosis would be able to play in this environment? Because obviously you're creating something that can be created in a sterile environment. And could you solve two problems at once by converting excess seawater from the demise of our glaciers and use that to create fresh water on land that is presently unusable or even usable, and thereby lower the level of the sea at the same time as creating usable land for farming and the like?
Some really interesting ideas in there, Richard. I'm not sure who wants to. Stefan, are you? Yeah.
I can start, and I mean it's a complex question, and we are an interdisciplinary team, so maybe I'll make a start and others chip in then and cover other aspects. And a question that combines a couple of great ideas. Some of them are, in particular in the Gulf and some parts of Africa, actually being implemented right now. So reverse osmosis is something that in areas that have plenty of energy, in particular solar energy, which is required for that, is developed. And colleagues from the School of Engineering in Birmingham are heavily involved in that with colleagues from our Dubai campus in the Gulf area. So definitely where there is plenty of energy, and in particular if it's renewable energy like solar or wind available, that desalinization of seawater can be part of a solution. a little bit of warning for the use of water for intensive irrigation. That's what you can see in a couple of North African countries and Saudi Arabia and other areas where intensive irrigation with desalinated water is happening. There are a lot of unintended consequences that we have to be aware of related to the movement of ions, in particular in the topsoils, the leaching of ions from the topsoils, and the fact that a lot of that soils have not grown over centuries, if not thousands of years, to sustain long-term agriculture. So quite often that type of agriculture that would be required would not necessarily be traditional agriculture like we are used to do, but there's a lot of research also done in Birmingham on hydroponics and other very smart ways of using substrate for growing plants and smaller amounts of water. And I think there's a big development in that area, but I let others talk now, so sorry.
Okay. Anything from any of the other panelists in relation to that rather challenging question?
If I just chip in really quickly from a sort of international kind of governance point of view, there's a really big interest, particularly sort of in Middle East and North African countries, around sort of solar desalination and scaling that up, obviously because of the renewable energy aspect, but also you get water at a lower price. And we do have some sort of commentators and NGOs working in that area who argue that solar desalination and reducing that water price could actually help contribute to blue peace in that region. So there's sort of interesting work being done at the moment to explore that possibility and how that could work in, say, a river basin such as the Jordan, whereas we're all aware there's sort of some real flashpoints of tension, and that maybe solar desalination is one of the things that will reduce those. Thank you.
Okay, thanks. Iseult.
Yeah, again, fascinating question, and certainly lots of activity and research going on in that broad area. And I actually teach a case study on that to my third years, where they have to do an environmental impact assessment of a desalination plant in Israel. But I think some of the challenge, I mean, I think as Stefan mentioned, the cost, or the energy cost, is generally very high. So solar energy is a really good potential there. And another of the big challenges with it is the biofouling. So the fact that the membranes get biofouled by all sorts of algae and bacteria and things in the water. But again, the combination of solar power and potentially nanotechnologies, so materials like titanium dioxide, which are photoactive and photooxidative, are offering lots of potential there. And it's certainly something we're looking at as part of our overall integration of particle-based technologies and solutions to address environmental challenges. So for sure, I think it's a potentially very fruitful avenue, but yeah, it will require still a good lot of research and a huge amount of investment.
Okay, great. I just want to remind everyone, all the attendees, please do ask your questions in the Q&A section. Please do keep your questions coming in. But in the meantime, I'd like to ask David a bit more about how we can adapt to the impacts of changing water availability around the world.
Thanks, Fiona. I think much of this has been covered. Human modification of the water cycle is far-reaching and is very complex, and it adds on top of the effects of climate change that I've mentioned, the roles of population growth, and also socioeconomic and cultural changes. In terms of adaptation and thinking about the impacts on the water cycle, there's two sets of interventions we can make, one on the supply side and one on the demand side. And when we're talking about the supply side, we're thinking about there how we can moderate the human influences on the terrestrial water cycles, how water moves through the land and through the subsurface. And we do that by changing the different stores and fluxes, so how water moves through the environment. We do this through land use, land cover change. We just recently had a paper appear in Nature Sustainability about how changes towards monoculture environments actually reduce the resilience of hydrological systems. But as Rachel and others have mentioned, we've also got the engineering and nature-based solutions that we can apply. On the demand side, that's all about some of the things we've also heard about this evening in terms of some of the technological solutions, like the last question, the legal and policy frameworks, but there's the importance of behavioral change, and also some instruments to think about more efficient use of water. But I think what we really want to move towards is a smart combination of both the supply and the demand side. And what I would say is that often, you know, the media sort of picks up on sort of water use efficiency, but we really need to recognize that actually in some contexts, particularly in low and middle income countries, that new supply side infrastructure is actually needed. You know, and this is in places where we're not talking about curbing water demand, but we're actually talking about providing water to meet the minimum needs for human health standards, as we've seen so clearly in the COVID crisis.
Okay, thanks, David. Can I ask Louisa Day to ask her question to the panel? Okay, Louisa, over to you.
Hi, yeah, I just wondered, when we hear global institutes like the World Bank talking about the invisible water crisis, what does that actually mean?
Yeah, Fiona, if I can start picking that up, and again others chip in. It's an expression that indicates that a lot of water quality issues we are dealing with, water pollution, is not visible. It is relatively well visible whether water is there or not. So the water quantity element is something we can observe as individuals. We see if water is coming out of the tap or not, if water is in a river or not, if our reservoir is empty or filled. Seeing whether water is polluted or not, sometimes it is mucky and dirty and it's pretty obviously polluted, but in many cases it's not. And to give you one example for it, where I've been working for a couple of years now in northern India on the Ganges. The Ganges itself quite often looks turbid, so it's has a very intense color. People know that it's full of organics, we often see a shift for in particular drinking water supply to groundwater, which seems visually much cleaner. But in many cases of India, of Bangladesh, contains really high concentrations of arsenic that are in parts even enhanced due to our use, because we mobilize a lot of that, and that causes disastrous rates of arsenic-related cancers. And it's probably debatable whether which of the two water sources is worse, but there's no perception for the impact of that visibly quite clean water. So that's why we call it an invisible water crisis. And it requires a lot of education about the pollution of water that can't necessarily always be seen, in order to make people aware of which water can be used safely, under what conditions, and how they can prevent using water that is in a condition that it does them harm.
Great, thank you, Stefan, and thank you, Louisa. We have a question that's come in that I'd like to put to you, which is about where your funding comes from your research. So I don't know whether you'd like to start. Perhaps David, you could tell us where your funding comes from for your research.
So I guess there's also director of research for the college. We get funding from a whole range of sources. We get funding from the UK Research and Innovation through a range of the research councils within that. But we also gain a large amount of research funding from the European Union, and clearly that's a risk as we move forward into the next year. We also gain funding from charitable sources of a whole range of different types across a whole range of different sectors. So it's a very mixed portfolio, which I think reflects the fact that lots of groups are very interested in water, and also the impacts they have on the environment, ecosystems, but also on people as well. So a wide array of funding sources. I mean, clearly one thing we'd like to think about is philanthropic donations and possibilities in that space. But I'm sure Darryl colleagues can speak more about that.
Does anyone else want to add anything on the funding sources for research in this area? Stefan?
Maybe just very briefly, as David said right at the end, there are a whole range of charitable funders and institutions like the JABS Foundation that supported and funded the Birmingham Institute of Forest Research, for instance, fund water-related research in the UK, and we see more and more investment by private donors, because clearly water is an issue that is affecting everyone, and the water-related impacts globally are affecting everyone.
And then if I might add as well, just building on that, particularly now as we're moving more and more towards a solutions-focused approach to the research, we're developing models where as the research moves sort of from lab or field or concept through to up what I call the technology readiness level, so through to being deployed or being suitable for deployment in real either industrial scenarios or really in areas where there are major pollution problems. We're also looking at building a sort of a portfolio model where end users, so such as industry or governments or things, are co-developing the solutions and co-funding the solutions. So really moving that sort of co-development and co-funding model forward as well.
Okay, we have another question. I'm going to read it out because I'm not sure that I'm fully familiar with the content of it. And that is water footprinting the new carbon footprinting for black belts? For example, innovation enabler and ESG circular economy multiplier for companies. So perhaps you may be familiar with the idea of water footprinting. So perhaps, I don't know if anyone would like to pick up that question.
I'll just offer a few sort of quick remarks from my kind of work. The UK government is committed to tackling its water footprint. And what it sort of means by that, when they talk about it, is how much water we're importing through our products, how much water we're using for agriculture. A lot of our food maybe doesn't come from the UK, the clothes we wear doesn't come from the UK. So what in water are we using, and how do we make sure that the water in those supply chains is sustainable? And there's a whole area of work going on from a lot of different countries. And I think we've seen campaigns around maybe the sort of big clothing companies that they should be reducing the amount of water they use. We've seen sort of bottled water campaigns. So there's quite a few sort of civil society and accountability campaigns going on. And in terms of relating it to the kind of carbon footprinting, we do have organisations such as the Carbon Disclosure Project, which has a water programme. So they're wanting to know how much water companies are using around the globe in, say, producing meat or clothing or drinks. So there's a lot of work going on there. And what we're finding is that the number of companies that are reporting to organisations such as CDP is increasing, but obviously still, it's not everybody. So how do we sort of bring more companies into that? It's sort of an area of work that people are looking at the moment. And then I'll hand back to you.
Any other comments from the panel on the issue of water footprinting?
Just very briefly, maybe it's interesting that it was mentioned together with carbon footprinting, and of course both water footprinting and carbon footprinting are intrinsically connected, and there was in particular in the beginning of carbon offsetting schemes, again, a lot of unintended consequences in offsetting schemes that may have helped us to reduce carbon or compensate for carbon use, but that use significant amounts of water, in particular in reforestation schemes, etc. So it shows again the wickedness of the problem.
It does indeed. Yeah, thanks for, a lot for that, Stefan. It really does. And I think the questions have been quite challenging, and they have, as you said, really sort of illustrated and fed in well to the theme of wicked water, and so water is a wicked problem. And I think the discussion, the questions, and the solutions we put forward have really tried to address the wicked water problem and its complexity. I think we've really seen that, and that encapsulated water footprinting idea is really illustrates that well. So I think we're getting quite close to 7 p.m. So I would like to wrap up by firstly thanking all of the panelists. I think they've done a great job this evening in really putting forward some very complex ideas and giving us a great sense of the important work that they're doing and how it really is relevant to policy and practice. So I'd like to thank David, Stefan, Iseult and Rachel for their great contributions, and thank you very much for giving your time this evening as well. I'd like to thank the alumni team for their behind the scenes support, and all of you, the attendees, for being with us this evening. Thank you so much for being here and for your questions. So I'd like to remind you that this series is continuing. So if you do have any particular areas of interest in relation to research and you'd like to see a webinar on that particular topic, please do get in touch with our alumni relations team and let them know, and they'd be really appreciate hearing your ideas and suggestions. We'll be sending around an email tomorrow asking for your feedback on this event, so please do look out for that and spend a few minutes on completing the survey. And next month, we'll have a panel including Professors Nick Lohman, Alan McNally and Alice Roberts on the topic of virology and COVID-19. So very topical, of course, and more information will be available on that in due course. So please look out for that and sign up, and I'm sure that will be a great evening and very informative. Obviously, it's a very dynamic situation as well with learning about COVID-19. So thank you again for being with us. It's been a great pleasure. I've learned a lot myself. A fantastic team we have at Birmingham working on many aspects of water quality, quantity and access.